Section 6.4 is binomials that contain radicals, and our objective is going to be to simplify the products and quotients of binomials that have radicals involved in them. The rule we want to remember is when we multiply binomials containing radicals, treat them as if they're regular binomials and go ahead and just FOIL. So example 1, we've got 4 plus radical 3, the quantity, times the quantity 5 minus radical 3. And what we're going to do is we're going to FOIL. So we'll say first, it gives us 20. Then outer 4 times negative radical 3 is going to be negative 4 radical 3. There's nothing I can multiply there. One's on the outside, one's under the radical. Then the inside is going to be 5 times positive radical 3. And then the last term here is going to be radical 3 times this negative radical 3, which is going to give me negative radical 9. We can simplify the middle terms. Negative 4 root 3, positive 5 root 3. Remember how to add these. Think of this part as like negative 4x and positive 5x. That would combine to give you positive 1x. So it's going to become a positive. Instead of 1x, it's going to be 1 times radical 3, or just radical 3. And then minus the square root of 9, which is 3, or minus 3. And then I can combine like terms. 20 minus 3 is 17. And then still plus the radical 3 from this part right here. So my final answer would be 17 plus radical 3. Part B, we have to go ahead and just FOIL again. Let's take a look at the difference here in part B. 2 minus root 6 times the quantity 3 plus 4 root 2. Well, the first term, doing FOIL, is going to give me 3 times radical 2. The outer term is going to give me positive 4 times radical 4. That's coming from the radical 2 times the radical 2, giving me the radical 4 at the bottom. And the inner term is going to be negative 6 times positive 3, or negative 18. And then the last term is going to be the negative 6 times the positive 4 radical 2, which is negative 24 radical 2. Going ahead to combine like terms, I can see that the first and the last can combine, and the second part here can simplify. This is really 4 times 2, which is just 8, and that's a minus 18 still. This 3 root 2 minus 24 root 2 is going to be negative 21 root 2. Okay, and this positive gets carried down here. And then I could simplify the positive 8 and the negative 18, giving me negative 21 root 2 minus 10. All right, let's take a look at part C now. Part C says the quantity 2 root 3 minus 4 root 5 all squared. And it's tempting to want to distribute the square to both because you see the square root. But remember that this is a sum or a difference. And whenever you have binomials with a sum or a difference raised to a power, you have to expand it. Okay, so start by writing it this way. We'll then do our FOIL method. First is going to give me 4 root 9. Outer is going to give me minus 8 root 15. Inner is going to give me minus 8 root 15. And last is going to give us plus 16 root 25. The middle terms are like terms. They can be added together. They're not canceled because they're both negative there, okay? Giving us negative 16 root 15. The first term is really 4 times 3, which is just 12. The last term is 16 times 5 times there, which is 80. So in the end, we get 92 minus 16 root 15. Part D says the following. 2 root 5 minus 3 root 7 times the quantity 2 root 5 plus 3 root 7. Well, let's see what happens here. This looks interesting because we've seen this before. If we FOIL this, we're going to end up getting 4 radical 25. Then the outer term is going to give me plus 6 root 35. Inner is going to be minus 6 root 35. And then last will be minus 9 root 49. Well, here what's interesting is that the middle terms cancel. And that happened once before when we multiplied binomial conjugates. Okay, binomial conjugates such as quantity x plus y times quantity x minus y. And that resulted in the difference of 2 squares. So we're going to see here, well, this is a square and this is a square, and we're going to have a difference. So this is really just difference of two squares. This becomes 4 times 5 minus 9 times 7, or 20 minus 63, giving us an answer of negative 43 unsimplified. So notice that when we have binomial conjugates multiplying each other, we end up getting the difference of two squares in numerical form, which give us integer values and an integer answer. So this answer is rational, even though we started with two irrational binomials. And these terms are known as binomial conjugates. Binomial conjugates. Let's take a look at simplification here. Well, what we'll notice right away is this. We have a radical in the denominator, and we've tried to rationalize already. We've done this before, where we just multiplied by the square root that was in the denominator. But now we'll notice that if we try to multiply by radical 5 over radical 5, it's not going to work, because we have this 2 here in the front, that the radical 5 would have to be distributed to both. But in the last example, we noticed that we always get an integer answer if we multiply binomial conjugates. So we can go ahead and multiply by 2 plus root 5 over 2 plus root 5. And what we'll see is that if we remember that we need parentheses here, first of all, okay, remember that they're there, the denominator must give me an integer, because those are binomial conjugates being multiplied. So the numerator, we're just going to distribute the 3 to both, giving us 6 plus 3 radical 5. But in the denominator, we start by doing FOIL, but we can remember that the middle terms are going to cancel. So we're going to get 4 for the first terms. Then outer is going to give me 2 root 5. Inner is going to be negative 2 root 5. Those cancel. And then the last part, when I do this times this, I'm going to get minus root 25. So this resolves into 6 plus 3 root 5. Well, this is just 4 minus, what is this number here? That's a 5. And 4 minus 5 is negative 1. So this is all over negative 1. So this could also simply be written as negative 6 minus 3 root 5, if you divide the negative 1 into both terms. Example B is no different, except for the fact that now we have a numerator involved as well, which we'll have to FOIL. So we've got, for example B, 4 minus radical 5 over 6 plus radical 3. We start by multiplying by the binomial conjugate. 6 minus root 3, 6 minus root 3. Remember, the goal is to make the denominator an integer, so we multiply by the binomial conjugate of the denominator. Don't confuse this and use 4 plus root 5. It's not going to work. It won't get rid of the denominator, just get rid of the numerator's irrational component. So if we were to FOIL the top, and we have to FOIL the top, unfortunately, the top is going to give us first 24, then outer is going to be minus 4 root 3, then inner is going to be minus 6 root 5, and then last is going to be plus radical 15. And the bottom is going to give me 36, but then the inner and outer cancel because they're going to be negative 6 root 3 and positive 6 root 3. But then the last terms are going to be the negative root 3 times the positive root 3, giving us negative root 9. The denominator simplifies to be 36 minus 3, which is 33. So the whole answer is going to be that numerator, because nothing simplifies here. We have no like terms. The radicals are not the same, so there are no like radicals. And we can't even break this up. We could try to think to break it up into 3 and 5, but neither 3 nor 5 reduce as a perfect square. So this whole thing is just over 33. And we leave this alone as our answer, because they're not all divisible by a factor of 33, like 3, for example. It seems as if we could reduce this by a factor of 3 and then also this, but these don't have factors of 3 in them. And finally, part C says 2 plus, or radical 2 plus radical 7 all over radical 3 plus radical 6. Well, these are still binomials, and we're still going to multiply by the binomial conjugate. So root 3 minus root 6 over root 3 minus root 6, okay, times our originals. Please remember to put parentheses around the originals to remind yourself that you need to FOIL here. So FOILing the top, you're going to get radical 6 for the first, then outer is going to give me minus radical 12, inner is going to give me plus radical 21, and last is minus radical 42, all over. First is going to give me radical 9, and then the outer and inner are going to cancel because we're going to have radical 18 and negative radical 18. And then the last is going to give me minus radical 36. Let's take a look at what we can do with the numerator to simplify this now. The numerator, we have root 6 here. Root 12 is really root 4 and root 3. This 4 is a perfect square. 21 cannot be reduced at all. And then minus our radical 42. Well, this is really 3. This is really 6. 3 minus 6 is negative 3 here. So what we're going to end up getting for our final answer for this problem, in the numerator we have radical 6 minus 2 radical 3 plus radical 21 minus radical 42 all over negative 3.